Hey everyone, today we're going to just practice some of the AP questions that are related to the rules we've been doing so far. So let's see how you would have done. All right. We're not going to do all of them. I'm actually going to let you do most of this on your own. So maybe this will be a shorter video. Um, but I want you guys to take a look at this is going to be called day 10 in your OneNote day 10 AP questions rules. Okay. And if you look all the way at the beginning, you should have more practice. I sent it to you already. So I'm hoping you see this question 2 plus 4x as the first one. All right. So this is a more straightforward question. And then they're going to get up to be a little harder. So I want you to look at this one, pause the video and try it, and then I'll come back to you. Okay. So first, what I would really like you to do is organize yourself like this, where you start with your original variable x, and you write the shape, center, and spread. And remember, that's how we describe a distribution with shape, center, and spread. And then I draw an arrow, and I create my new random variable y, and I write shape, center, and spread again. And I write the equation that defines the variable y, which is 2 plus 4x. So if it has been transformed, the shape will remain the same, which is normal. The center will do exactly what we predict it's going to do. So it's going to be 2 plus 4 times the old mean. So I'm hoping that you did 2 plus 4 times the old mean, which is 5, and that's 22. So if you know that the new mean is 22, then you already know that you can eliminate choice A and B because that's wrong. And then the spread, remember, adding a constant, which in this case is the 2, will drop out and it will not influence the spread because when you add a constant, everything moves over by the same amount and the standard deviation remains the same. So the 2 will not impact the spread, only the 4 will. So all you have to do is multiply the 4 times the old standard deviation, and that'll be your new standard deviation. So 4 times 25 is 100. So your final answer should be choice D. If you've got choice D, good job. Give yourself a pat on the back. Okay, so now if you have a question like this, read it and see if you can create the equation because they didn't give you the equation like in the last one where they gave you y equals 2 plus 4x. Here they're describing it in words. So here they say if the value in a sample, so if x is the value in the original sample, has been transformed by multiplying by 3 and then adding 10, okay? If the original sample has a variance of 4, I want you guys to underline that. What is the variance of the transformed sample? Okay, so think about it. Again, stop the video for a second and think about it. So, all right, so the first thing is, remember in the last question, we said that the 10 will not play a role in the spread. So you can cross out the 10. The 10 will not play a role, okay? But the 3 will. So really the question is going to be, are you going to multiply 3 times 4 and get 12, which is choice B? Or is it a little more complicated than that? Okay. And obviously I'm spending time on this, so it's probably a little bit more complicated than that. Remember, variance is standard deviation squared. So if I want to get the standard deviation, I can by taking the square root of the variance. The square root of 4 is 2, right? Now, you can go over here to the standard deviation and you can multiply 3 times the old standard deviation of x. Because remember, the 3 is going to play a role in all the values getting more spread out. So you're going to do 3 times 2, and that's 6. And you think you're done, but that's the standard deviation, remember? So to get the variance now, what are you going to have to do? I'm hoping you're going to say you're going to have to square it. So now you're going to square the 6, and you're going to get 36, okay? So the answer was not the more obvious answer, which was 12. The answer was choice E, which is 36. And that's because even though you think that you're multiplying 3, you're not multiplying 3 by the variance. You're multiplying 3 by the sigma. And if you think about it, the 3 times the sigma when it gets squared is actually going to become 3 squared sigma squared, and 3 squared is 9. So 9 times sigma squared is going to be 9 times 4, which is the same thing, 36. So the way I did it was maybe like a little bit longer, but just mentioning that it may be easier to work with standard deviation, not variance. So I first square rooted to get the standard deviation, then I multiplied the 3 times the 2 and I got 6, and then I squared it back up to get the 36. But maybe some of you will understand that if the 3 is being multiplied by the standard deviation, when it will become squared to become 9 and then multiplied by the variance. So now here's where we get into more application-based questions where it's just less about like numbers and more about actual real life scenarios. So here we have X is a random variable of the values of the number of dots that appear on a die. So basically how many numbers are on a single die, right? 1 through 6. It's telling you the mean and the standard deviation. Actually, no, the variance, sorry. So let's write X equals the number on the single die. They're telling you the mean, which is the expected value, is 7/2, which is 3.5. So just so you know, if you added 1, 2, 3, 4, 5, and 6 and divided by 6, or if you had put 1, 2, 3, 4, 5, 6 in L1 and you found one var-stat, you would get a mean of 3.5 because the average of 1 and 6 is 3.5. And the variance is 35/12. Okay, so let's let y be the random variable of the difference if we did this twice. So this is basically saying x minus x. So for example, let's say I had 6 on the first roll and 1 on the second roll. 6 minus 1 is 5. Y would be 5. Let's say I had 3 on the first roll and 3 on the second roll. 3 minus 3 is 0. So basically that's the difference here. What is the standard deviation of y? Okay, so they're asking for sigma. Okay, so let's again go back to the original. If sigma squared is the variance of x, let's square root that to get the standard deviation of the original x, right? Now, let's go back to our rules of random variables from yesterday or whenever we did this. Are we allowed to work with standard deviation? We're actually not. We have to work with variance. So maybe I should have stuck with this. And do variances subtract? The answer actually is no. The variance is add, okay? So basically, if you know that the variance is add, because the negative squared is going to become a positive, then you know it's going to be the variance of x. Negative is still going to become a positive, the variance of x, okay? So that's one of the rules of combining random variables that you need to know, is that you work with variances. Variances add, the negative squared becomes a positive. So we're going to do 35/12, which is the original variance, plus 35/12. We get the combined variance, but then we have to square root that to get the standard deviation. So the answers, if you look, it look like B and C kind of look similar, but notice that C is the one that we want because you're first adding them together and then you're square rooting them, versus this one is like separate. B is actually showing the sigma of x plus sigma of x, which you're not allowed to do. You're not allowed to add standard deviations. That's what B is. That's out. And D is saying subtract, but you know better than that. You know you never subtract with the rules of random variables. You only add. All right, here's where it gets a little harder. Read this question to yourself, and then we'll talk. Okay. So let's say you're playing a video game, and you are earning points for doing something correct. In this case, they're letting X represent the number of cards moved to a correct position. That's X, okay? So you earn 5 points for every time you move a card to a correct position. So I'm going to go like this, and I'm going to put +5 here, and that's going to be a +5, but it's actually going to be multiplied, because let's say I moved 5 cards to the correct position, I would do 5 times 5 to get 25 points, for example, okay? So this is a +5. And then it says, so now let's say you're playing your video game and you get docked by how long it takes for you to play the game. So the number of minutes that it takes you to play is going to be multiplied by -10, because you're going to be penalized 10 points for every minute that you play. So we're going to multiply the y by -10, okay? So you're earning points for x, and then you're basically getting subtracted points for y. So now it says the mean and the standard deviation of these individuals. So this is the mean of x, and this is the mean of y, standard deviation of x, standard deviation of y, okay? So it says, what is the expected value and the standard deviation? Let's start with expected value because it's easy. Remember, expected value means the mean. And remember, we would multiply, and add. So we would multiply whatever the weighted x value is by its weighted probability, and then we would add to get the expected value in general. So in this case, we have to take our mean. We can multiply it by 5. I'm going to call this total, E total, expected value total. So we're going to do positive 5 times 9.5 plus -10 for loss times 5.4. So do that, and you're going to get your expected mean, expected value. So I ended up getting -6.5 because the expected gain of number of points is 47.5, and the expected loss based on the number of minutes you play is -54 or plus -54. So when you combine that, you get -6.5. And so that means like overall, you're probably going to lose. And specifically, you're going to lose by an average of 6.5 points. So based on that, you can already eliminate C, D, and E, which is pretty nice, right? So now I want you to think about standard deviation. Are we going to be able to do the same thing for standard deviation? Are we going to be able to multiply 5 by 12.9 and -10 by 1.1? And are we going to be able to add those up? Ask yourself that question. I'm hoping you said no, you cannot do the same thing. What you have to do is you can multiply 5 by 12.9 to get the standard deviation of x, right? But you're not allowed to work with that. You need to work with the variances because if you want to combine them together, you actually have to get the variance. So you're going to, once you multiply 5 by 12.9, you're going to actually have to square that number to get the variance of x. Separately, you're going to do -10 times 1.1, -10 times 1.1 to get the new standard deviation of y, and then you're going to square that to get the variance of y. And then once you have your two variances, then you're going to be able to add them, because remember, variances add. And then you're eventually going to square roots, okay? So right now, I want you to do 5 times 12.9. Whatever you get, square it. Then do -10 times 1.1. Whatever you get, square it. And write those numbers here. Then add those two together, and that's going to be the combined variance, and then square root and see what you. Okay, so I ended up getting choice B, which is 65.3. 65.43, sorry, 65.43. And here's my work, if you want to see it. I multiplied, squared, added the variances, square rooted. Okay, this is the last one I'm going to do with you, and then you guys are going to practice the rest of this document yourself. Take a look, read it, and then we'll talk. Okay, in this question, we have a total basket full of a total weight of 4 apples, 6 pears, and 1 basket. So I set this up where I wrote W equals the total weight, 4A plus 6P plus 1B. And then I want to show you, if you break this down, this is really 4 apples. So apple plus apple plus apple plus apple is a grouping of 4 apples, 6 pears, and 1 basket. Okay, so I want you to think about these apples kind of like you would think about yesterday when we did the runners on the track team and how we had to individually, we had their distributions of times and we had to add them up to find the mean of the time of the team, the mean team time. But for the standard deviation, we couldn't do that. If you recall, we had to find the variances and then add them and then square root to get the standard deviation. So similarly here, we can't work with the standard deviation column. We have to actually square them to get the variances, and then we can add them up, okay? So we're going to take 0.20 for the apples and square it, and we're going to get the variance of the apples, and there's going to be 4 of them. So the variance of one apple plus the variance of another apple plus the variance of another apple plus the variance of another apple, okay? You get the idea. So there's really 4 of them, right? If you want to write it like that, if that's easier for you. It's a grouping of 4 of the 0.20s. And then we have 6 pairs, right? So same thing. You can either do 0.18 squared plus 0.18 squared 6 times, or you can just do plus 6 times 0.18 squared. That's the variance of the pairs. And then the basket, there's just one of them. So plus 1.88 squared, okay? So basically, if you do all this, this is going to be the variance of the total. And then after you do all that, you're going to do the square root, okay? So you can do it now and see what you get. All right, so the final answer I got was choice B, 1.97. All right, so now you see a variety of fun, exciting questions. There's plenty more here. You can do this one. This one is a lot more straightforward. You could try this one, this one. You can even try some of these free response here. See what you can do. All right, there's plenty to do. Good luck. I would like you to actually try them, so please challenge yourself to at least get through the multiple choice.